Okay, so it's 4 o'clock. We might as well get started. Hi, I'm Bruce. I'm a PowerShell alcoholic, like the rest of the world. And today I want to talk about something I've been working on for the last, I don't know, year plus, a little personal experiment. First, we thank our sponsors, of course. I got a demo of script runner the other day, and it was awesome. I'm really impressed with it. So, Bruce Payette, I was a founding member of the PowerShell team. Jim Truer, I think, is the only one who's left still on the PowerShell team. In my role, I was the lead, tech lead and the architect on the language and the engine, the pipeline engine. I also invented DSC and wrote a book that some people may have. So I was an architect, I was a principal software engineer at Microsoft for 18 years. And then I spent a couple of years at AWS. And right now I'm doing my own thing because I want to have some fun. So, quick review. So what's a shell? In this context, shells are user interfaces that provide access to the kernel facilities. So the shell wraps the kernel, rather obviously. They're also very high-level programming languages. Most shells work exclusively with text. They pass around strings to and from external programs, which makes them a little bit slow. In contrast, PowerShell is a cross-platform object-oriented shell. So it passes around objects that have named types and observable structure. And this significantly evolved the shell paradigm. As an aside, looking at the state of the shell talk earlier, in the last few years, the environment around PowerShell has improved a great deal, but there hasn't been a lot of change in the language. And I refuse to believe that we got it right the first time. I think there's a lot more that can be done. So how do they work? Talked a little bit about that. We pass strings to and fro. Everything is typeless. PowerShell is typed. And then Braid builds on top, literally builds on top of PowerShell. That is, it's hosted in PowerShell. Shell syntax, this is actually important. Shell syntax is command and arguments. PowerShell actually has two syntaxes. It has command mode, which is what this is, and it has expression mode. Expression, which means there's certain complexities to the syntax. You have to remember what mode you're in. In pure shell environments, there's only one syntax, and that's command and arguments. They pipe together, so they compose through piping. They can nest and can be nested to arbitrary layers. If you're a language geek like me, you would recognize this pattern because it looks like Lisp. Who here knows what Lisp is or has heard of it? It's one of the oldest programming languages out there. It's a Fortran vintage. It's also one of the easiest programming languages to implement because it's just a list of things that you call. Modern Lisps have been extended to support objects. So we have something like Clojure, which is a Lisp for the JVM, and it does things like treating methods as functions. Everything in a Lisp language is a function. And so instead of saying hello world dot length, you say dot length hello world. That's weird, but it actually has certain advantages. Likewise with methods, you can do substring on hello 2 + 2. One of the problems with Lisp is that you get a lot of parentheses very quickly. So the top line there, the sum, map, etc., is pure Lisp syntax. But if you take the pipeline from the shell and you apply that, then it greatly reduces the complexity. And when you're in the interactive environment, you can just omit the whole top set of parentheses. So let's start Braid. So this stuff's all up on GitHub. What the script does is it checks to make sure that that Braid is not out of date and rebuilds it if it has to. So ls, no surprise. So map is like for each in PowerShell. It's traditionally called map in functional languages for mathematics. And so I'm calling it map here. And you'll get an error. The reason you get an error is that Braid is strict. That is, in PowerShell, if a property isn't there, then it just returns null. so that you can hide errors that way. So what I've done here is, by default, properties are strict. If the property doesn't exist on the object, you get an error. If you want to go out of your way to say that the absence of a property is fine, then you can use this notation. That gives me, you can see the nils are all of the directories. I can use, so file is just get child item. So it has all of the properties of get child item. So in this case, file. So now I know I'm only going to get files, I can run it without that. If I want to know what the total of the links are, then I can sum them. And this is another deviation from PowerShell. PowerShell has measure object. Measure object does sums and counts and standard deviation and a whole bunch of other things. And the problem with that is that when you actually want to use one of those values, you have to add another step in the pipeline to extract the value from the rich text object. So sum, I can get the average. Let's do something a little more interesting. The read file function reads and returns a list of lines from a file. So you can give it file, and I want to count those lines. And now I can sum them. So that tells me the number of lines in the files in this. Let's just do the Braid files. Let's recurse. So there's a fair number of lines in the Braid files in this. These are files written in Braid script language. We can also get some of the C# source files. So there's a little under 30,000 lines of C# that make up Braid. So looks like Lisp, simplifies the pipeline, simplifies the nested parentheses syntax by using the pipeline, and when you're doing interactive things, you leave the top level. This makes it a shell. I sort of hit on the idea of getting rid of the top level parens when I was at another conference. Up until that point, it was just too annoying to use it as a shell. But surprisingly, that one little change to get rid of the top level parens make it usable as a shell. There's a whole pile of other features in Braid, and we'll look at some more of them. Subject-oriented shell that's based on top of PowerShell and .NET. We just looked at these examples. It has an extended Lisp syntax, adapted from a couple of other Lisps that are out there. It actually has array literals that are in square brackets. PowerShell doesn't have array literals. It has an array operator, the comma, that can produce some weird side effects sometimes. Yeah, I know the pain. So Braid has actual array literals, and they nest properly, et cetera, et cetera. It has set literals, or it has dictionary literals, so hash tables, slightly simplified from PowerShell. And it has set literals, which PowerShell doesn't have. A set literal is just the presence of a key is there or not. It doesn't have a value associated with it. Function literals, I think I showed that a second ago. Function literals are the equivalent of script blocks. And they use a notation that, well, it's close to Church's original Lambda notation, if that's not too obscure. It also has regular expression literals. And this is a feature I think that PowerShell could really use. If you use a switch statement, you either treat all of the match cases as literals or as regular expressions, depending on which parameter you pass to the switch statement. You can't have a mix of literal strings and regular expressions and expect it to work. So that you lose flexibility in the switch statement because of that. By having regular expression literals, you can mix and match patterns. It has to exactly be the string, or it has to match this regular expression simply by specifying a different type of object. And then it has patterns. If you can see the line there, match P is kind of like switch. The clauses are separated by pipe symbols. The argument to the left of the arrow is the value to match, and the argument on the right of the arrow is the value to return. We'll look at that in more detail. The other thing is that everything is a function. So regular expression is a function. So you might have to write, like if you're in PowerShell and you wanted to match against a regular expression, you'd have to write a script block that had $_match and then a string. Here, it can be simplified to where and then pass a regular expression. Because it's a regular expression, it knows how to evaluate it as a regular expression, not as an object literal. And finally, and sort of weirdly, arrays are in fact functions. And so you can take an array and pass it an argument that gives you an index, or pass it 2 arguments and it will replace the indexed element. More features, type literals. PowerShell's type literals have square brackets around them, which is why we couldn't use square brackets for array literals. I wanted to use square brackets for array literals, and so type literals use a caret to indicate that that it's a type. Long integers are supported with the I suffix. Numeric literals, you can have floating point, you can have hex literals, binary literals, and you can also put dashes in your numbers. Jeffrey asked me probably like 4 years ago whether we should adopt this in PowerShell, and at the time I said no, and I was wrong. This really does kind of help. Let's see what else. So no operators, just functions. So if you're adding 2 numbers together, you write +1, 2. You don't write 1 + 2. Again, that's strange. You get used to it. Quickie demo here. So +1, 2, yay! But it means I'm not limited to only 2 arguments. I can have 3 or 4 arguments. And then you can do something like this, where so we have a range. So it just returns an, oh, interesting. Not each. So this just range operators like the dot in PowerShell, it just generates a sequence of numbers. It actually returns an enumerable, not an array, so it doesn't take up any space until you actually access it. But because we can do that, so we'll use multiplication. We will splat the range. So that's a factorial of 10. So I can create a factorial function. Arguments are in square brackets. So now I have a factorial function. So you can get big integers. But it's very easy to make functions like that because you can combine the functions in a very sophisticated way. We looked at function definitions. We looked at a standard function. There are also pattern functions. So as well as the match statement or match function, you can define a statement, a function that will take a pattern as its arguments. And this gives you some of the capabilities that you get out of parameter sets in PowerShell, because you can have multiple alternatives in the pattern set. Braid supports interfaces and classes. So you can define an interface with a def interface. You can define a type with a def type. Again, no operators, just functions. Quoting. And you may have noticed or not noticed when I was typing things. I typed a tick in front of the string startup PS1. So this is kind of the opposite of PowerShell. In PowerShell, an undecorated string is just a string. If you want to get the value associated with that string, you put a $ in front. This kind of flips it. By default, you get a value associated with a symbol, and if you want to suppress the evaluation, you use the backtick in front of it. It's a learning curve, but it's not too bad. Compound symbol for destructuring. This is a decision I made that's a little weird. In this case, the colon's not an operator, it's actually part of the symbol. So you have an inherent compound variable type. And we'll look at how to use it. So I have a compound symbol with two components, F and R. Now if I look at F, whoop, it's 1, and R is the remainder. So I got the first item and the remainder. Well, let's change this a little bit. I'll put a trailing colon on it. This now says that it requires an array of exactly 2 items. And if I try and assign it, it'll fail. Failing is not all that useful, so there is a conditional assignment function, and now it'll tell me that it's false, which I can then use in an if statement. Too many friends. So yay. Property patterns, I'm going to flip into a little lost in my slides here. Well, see if I typed it correctly. I did not. Okay, so this succeeded. And if I look at the value n, that gives me the process name, and I gives me the PID. So I can extract properties using pattern matching. And again, you can use conditional matching so that if it doesn't succeed, then it just returns false. So you can use this in patterns and in regular assignments. You can write a while loop that while the pattern matches, do an action, otherwise stop. So compound symbols for destructuring, we have property patterns. Compound symbols destructure arrays or lists. Property patterns destructure objects. In terms of flow control, so PowerShell has a bunch of keywords. It has an if keyword, it has a while keyword, and so on. There are no keywords in a Lisp. They're just special form, just another type of function. And so if it's just a function, so that's just a function. Same as plus, right? They're not. Well, they're a little bit special, but end users can write them. Anybody can add their own control structure to the language. This is both wonderful and annoying because people can write a while loop that only executes every second item or something like that. Yes, question? Sure. Actually, I think I marked some constant in the global scope. The question was, can you override the built-ins? And the answer is probably not in the global scope because I think I've marked them all constants. But you can have a local scope that overrides it. So you can create your own if statement inside a function, for example. As higher order functions, this is a big deal in functional programming, the idea that you can have functions that take functions as arguments. This is an everyday thing in PowerShell. Script blocks are higher order functions. We don't call them that, we call them script blocks. And nobody seems to have a problem with it, which is kind of amazing. This big concept that just kind of works. So one of the things that is nice here, though, is because operators are also just functions, you can do things like use the reduce statement. What the reduce statement effectively does is apply the operator between each item in a list. So and again, we can do the factorial thing. So you can just, I want to square all these numbers. There's a square function, so you can just square them. You can't do this in PowerShell because functions and variables live in different namespaces. So you could do it by saying $function : the name of the function, to pass it as a first-class object. But you couldn't do it with variables because they just don't exist in that namespace. One of the big decisions that we made in PowerShell early on was how scoping should work. Shells are historically dynamically scoped because they're shells calling shells calling shells. It's just a side effect of how environments are implemented in operating systems. That we had more choice, but we chose to emulate the standard dynamic scoping that most shells have. I didn't do that in Braid. I made it lexically scoped instead. Lexical scoping allows you to have real closures. I think somebody's doing a talk on PowerShell closures later this week. A closure is basically a variable capture. So if you look at this example, make counter, it defines a variable n and then returns a function literal that increments that value. And that value gets captured in the closure. So and you'll note that the function I'm returning doesn't actually take any arguments. There's nothing between the backslash and the arrow. Instead, its environment comes from its enclosing lexical scope. Needs a number. Right, so it gives me a function back. Let's see. I'll create another counter. So they've captured the variable and it becomes private state. The way I think about it is that in object-oriented programming, you have data that has methods attached to it. With closures, you have functions with data attached to it. And it allows a set of very powerful programming constructs, continuation, passing, and so forth. So lexical scope, explaining lexical scoping, I haven't done a good job. You either understand it already or you won't know what I'm talking about. Yes? Mm-hmm. The paren? Yeah, that is the function. Actually, it's macro that says the rest of this thing is a function. Yeah, it could be lambda, it could be whatever. Backslash because that's what Church used in his notation. Tail recursion. So PowerShell is not tail recursive. Tail recursion is if you call a function recursively, it puts a new stack entry, or puts a new entry on the stack. And so after a while, you run out of stack. Tail recursion unwinds the stack to the previous level and then calls the function again. And this has the advantage of allowing you to do arbitrary This one's too long to type by hand. So that's just a function that reverses a list. Reading into the function, it says the first pattern clause matches a list that separates the first item from the rest of the list, and it takes a second optional argument that is empty. If this pattern matches, then it does a recursive call using the remainder of the list to reverse, and then adds X to the list of the result list. If the input list is nil or null, then it just returns R. So that's how it reverses a list without doing any looping. And it works with 10 or 100 or... That would completely blow the stack in any programming language that didn't support tail recursion. People asked early on if PowerShell was going to support tail recursion, and I didn't think it was necessary, but it actually is pretty cool. It lets you do certain types of algorithms in a very effective way. So metaprogramming. Metaprogramming is programs that manipulate programs. Higher order functions are one of the simplest elements of that. There's something called a special form, which the if statement, the while statement, and so on are instances of. The difference between them and regular functions is that a regular function receives its arguments already evaluated, and a special form receives its arguments unevaluated. And that's how if can look at the conditional expression passed to it. It calls eval on that conditional expression, and then decides whether it's going to execute one or the other of the other expressions. There are a couple of functions that help you write those, upvar and do. Updo, they allow you to take a chunk of code and say, execute it in my dynamic caller's scope. Again, it's hard to explain. I have some examples in the test suite and so forth. How am I doing on time? Not well. Eval, everybody knows that eval is evil. Except that eval in Lisp is not, because it doesn't take a string. It takes a constructed list. And so before you can get user input is a string, you have to sanitize a string before you call eval. Well, for Lisp to work, you have to actually process that string into a list before you can evaluate it. And so in doing that processing, you have to go through the evaluation state. It has to be syntactically correct. And then macros. Macros are yet another type of function. Like special forms, they don't receive their arguments evaluated, but they're executed at compile time, not at runtime. And so a macro, the job of a macro is to generate code. When it gets executed, it takes its arguments and returns a new block of code to be put in its place. A little bit like C++ templates. And so there's a for loop, for I in whatever type of loop. And this is the code for that function, or that macro. There's some constructs in there that I'm not even going to try and explain, but I'll show you how it might be used. So if you look at this, you can see how the for statement has been transformed into a do block that defines a local variable I, uses the conditional in a while statement, and does the increment at the end. So it's generated new code. Let's just run that. Assuming I got it right there. So that the key thing about that is the transformation is done once at compile time. So it's efficient. You can generate arbitrarily complex code at compile time in the compiler. It means the compiler is user extensible. And that's a standard Lisp function. Performance. This is an interesting one. Braid's dispatch mechanism is much faster than PowerShell's. PowerShell's parameter binder is slow, really, really slow. So you can see in this little example, let's actually do the example. So I have a Fibonacci function. A Fibonacci function written in Braid using pattern matching. So if the argument is 0, then the result is 1. If the argument is 1, the result is 1. If the argument is anything other than that, then it's the sum of the previous two Fibonacci sequence elements. How's that for a great explanation? This is the equivalent in PowerShell. So I can run them. It doesn't take very long. But PSVIP is way, way slower. Because I can't math, right? It's nearly 20 times slower. Which is basically, there's no reason for PowerShell to be that slow, I don't think. I think that if the PowerShell team invested the time to optimize the parameter binder, especially in simple cases, then there should be dramatic performance improvements. PowerShell is faster than Braid in exactly one scenario, and that's where you're using a for loop with calling no commandlets or functions or anything like that, just for I equal 1 to 100 kind of thing. And this is, I had to work hard to find it. And it has to be compiled. The interpreter is still slower. Some simple examples. I'm a little over time. We already looked at some of these things here. We're doing group by. So I want to find the number of types, type of file of each type of file in the directory. I think I need some water. So here I'm passing in two function literals. It can be greatly simplified since methods are functions and properties are functions. Then I can just say, take the input from ls, group it by extension, and then count the number of keys of each key. Or I could use it with, I can just pass in echo, which just repeats the argument value and count just as the counting. And then finally, I can just get a list of the keys by mapping key against the group counts. Slightly more complex examples. The top one finds out how many classes there are in the source tree, in the C# files. This one gets all the C# files. Flat map is a variation of map. The for each in PowerShell is equivalent to flat map in functional languages, in that it flattens all of, if the script block returns a collection, that gets flattened into the overall collection. Everything gets streamed out. Map, if map returns a collection, then you have a collection in your collection. If flat map returns a collection, then it gets streamed. So flat map, read the file, filter by the public classes, and then replace the text of the class and just keep the name. So we're using back references and then sort the result down descending. So it does a fairly complex function without a lot of work. Working with processes, this one is kind of cool. It gets a list of all the processes, figures out all of the processes that have a particular module, a DLL loaded, and then returns it by DLL. So each entry in the group is a DLL, and the value of that group is a list of processes that have that member, if that sounds correct. Basic recursive, we looked at this. You can write a recursive function using standard functions, or you can write it using pattern matching functions. I find the pattern matching syntax very compelling. It is something that I think PowerShell could benefit from greatly without mangling the syntax too much. The switch statement could be altered in a non-breaking way to support proper pattern matching. The switch statement, I was very excited about the switch statement when I put it into PowerShell, but it just ended up being a little too awkward to use in a lot of scenarios. I think with a little bit of work, it could become extremely powerful. Windows Forms. So I have a pseudo module for doing Windows Forms. Just create a form object, set the text property. Again, one of the things that's different. Normally, when you set a property in a language like C#, it's void. It returns nothing. In Braid, if you set a property, it returns the original object. So it lets you do the builder pattern for free. So this is sort of working with raw classes, and then a slightly tarted up DSL, so you can just specify the different properties you want. It supports concurrency, so there's async await. You can fire up a Lambda asynchronously and then do a join later to get the results. 3 web pages concurrently using map parallels. This is just wrapping link, basically. So anything that you can do in link, you can do in Braid. Demos, I have no time. Let's do one. Whee!